welcome back. So this is our fourth, I don't know, next video in the series about acceleration. This one, I guess, is number 4, has to do with taking a little bit of a deeper dive into looking at some velocity time graphs and sort of interpreting them and sort of being able to get information or kind of being able to see the story, I guess, that's in a velocity time graph. With these, I guess the one big caveat to begin with is that our brains don't really work in terms of velocity time graphs the same way. Position time graphs tend to be much more instinctive for us to interpret and think about moving forward, moving backwards, etc. There are certain things about velocity time graphs that are pretty instinctive, but on the other hand, there's certain things where you look at it, your initial impression from looking at a VT graph can really be a little bit misleading, kind of lead you astray. So this particular video, most of it is actually examples of different VT graphs. And then for you to get the best best help out of this would be when I pull up a VT graph after the first one or two, kind of hit pause and then walk yourself through it. What does it mean, these different kind of regions in the graph? And how is the object moving? Is it stopping? Is it accelerating, etc.? And that will certainly help you kind of learn to interpret VT graphs and just get a little bit of practice with it. So a couple of things that we're going to take a look at in here is being able to talk about what does it mean to be positive and negative velocities, to be interpreting what happens with slope and what the slope actually means on VT graphs versus what it meant in a position time graph. And then finally, a really key thing that we have is what does it mean when a line on one of these VT graphs crosses the x-axis is a really important landmark. So if you can kind of keep some of those things in mind as we go, that may help you kind of wrap your brain around this. Like I said, these aren't that hard. They're just different than your brain is kind of used to instinctively interpreting. So here's example number 1 or slide number 1. And again, what I would suggest that you do is for each one of these graphs is kind of hit pause after this one maybe, and then kind of talk your way through what's happening. So I'll talk about the red line, then I'll talk about the blue line. So let's talk about interpreting these. What's happening in these graphs? What's going on? So we'll talk about the red line first. So if you take a look at this, again, remember that when we're talking about velocity time graphs, I'll move this out of the way so I get to my pens because I need that part. When we are talking about velocity time graphs, we've always got velocity on the y-axis. We've got time on the x-axis. And then we almost always, when I draw these, we'll have a 0 line right here. So a lot of times we'll kind of do the plus region up here and the minus region down here. So what I would suggest is that in your head, rather than thinking of this as being forwards and backwards, I really like to think of it in terms of north and south, or better yet, east and west is a really good way to do this. So typically I'll interpret this as east, which would be like to the right on this drawing, and this would be west. Just to kind of, again, getting away from thinking about it as like forwards and backwards. It's more like, east and west is a little bit better way to think about kind of what they are. All right, so with this one, our first one that's up here, I don't know, position A or whatever it is, what's happening for this guy? Is he holding still? At a position time graph, we would say, oh, he's at position 5 and he's staying at position 5. And that's not what this means here. So think about this. You can put some fake numbers in this if you want to. This means its velocity is positive 5, and then positive 5, and then positive 5, positive 5, positive 5, positive 5, positive 5. It's moving at constant velocity, and its positive direction, whichever way that is, like east in the mind or north or whatever you want to call it. But it's not changing. Its displacement would keep going up, but its velocity is constant and positive. So in other words, it's moving in the positive direction. And for whatever bluish kind of one, blue-green, I don't know what you want to call this, what's happening here? All right, well here, velocity is equal to 0, 0, 0, 0, 0, 0, 0. So at 0, holding still. Right? So here, it simply means that whatever its position is, it's holding still at that position. It's not currently moving. Keep in mind its displacement could be at distance equals 0, could be a positive distance, could be a negative distance. We can't tell from looking at this. We just know that it's not currently moving at this particular point. Holding still, velocity equals 0. Okay, so holding still, by the way, horizontal here means constant velocity. It says constant velocity here is equal to 0. And then what's happening? So now we're going from 0 to -1, -2, -3, -4, -5. So it's going to -5, and now it's staying at -5. So here it's changing its speed, and here it's going a negative speed, right? So here it's going constant velocity of like -5 or whatever you want to do in the negative direction. Here, what is it doing? It's going from 0 to -5. So this is accelerating. There's a slope. And it's accelerating in the negative direction. It's got a negative slope to it. Actually, it has a positive slope to it. But it actually, no, it's a negative slope. Sorry, positive goes up. Negative slope. So it's got a negative slope in the negative side. So again, it's going from 0 to -5 over a couple of seconds. It's accelerating. And then here it is stabilizing out again at that constant velocity. All right, let's take a look at a couple more here. All right. Example number 2, we've got 2 things here. We'll take a look at interpreting our signs of acceleration and velocity, in particular in these. These all have changing velocity, right? Not constant velocity. There's positive slope on both of these. So we've got the red one and then the blue one. So which one's faster? Well, it depends on what time you're talking about, right? Which one's faster? A lot of times students will say, well, the red one's faster. It's not what this means at all. Because not necessarily is that true. They're both going 0 at one point in time. Both of these are starting from stopped. Again, remember, this is the 0 line for velocity. So this is stopped and moving in the positive velocity direction. And this one is stopped and moving in the positive velocity direction. At any particular time, they could be going the same speed. So be careful a little bit how you interpret slope on these. This one definitely has a steeper slope than this one does. So what does that mean? If this one is going from 0 to say +10, and this one's going from 0 to say +5 over a certain amount of time, what exactly does that mean? Well, here again, we've got velocities going in our east direction, positive, whatever that is, and it's going from 0 to +10. This one starts a little bit later. It's going from 0 to +5. So what does it mean when it has a slope? This means it has acceleration, right? As soon as there's a slope, it means it's accelerating. If there's 0 slope, there's 0 acceleration. The slope of a VT graph is acceleration. So this one has greater positive acceleration. This one has less positive acceleration. In other words, this one's not speeding up as quickly. This one's kind of hitting the floor a little bit more, right? Yeah, hammer down a little bit, accelerating more quickly to it over a certain amount of time. Again, the amount of slope is how much is it increasing its velocity for any particular range. So now this is a positive slope, right? It's going in the upwards direction. It's a positive slope and positive velocities, so it's speeding up. This one also has a positive slope, although it's less positive, right? The magnitude of the acceleration here is a little bit less, but it's got positive acceleration and positive velocities. Therefore, it is also speeding up in that particular case. So these are both speeding up. They are both going in the positive eastward direction. This one's going from 0 to 50 or 0 to 10. This is going from 0 to 5, a little bit faster, a little bit slower in terms of their rate of acceleration. Move on to number 3 here. Okay, here these are going the other direction. So now we're going down in this particular case. So what's happening with these? So now both of these come to a stop. It's important to notice that whenever they hit that, that means, again, that your velocity is equal to 0. So this one's starting at a positive velocity, and both of these are coming to a stop at some different time. The red one stops first, the blue one stops later, but still, they are coming to a stop. Let's say this one's starting at +10, and it's gradually or steeply going down to 0 at the end. Maybe this one's starting at +5, and this one is also going down to 0 at the end. So they're both going from a positive velocity to 0. So what does that mean? These both have acceleration. Again, it's not a flat line. It's got slope. It has acceleration. This one has acceleration. What direction is it? Well, our acceleration here, our slope here is negative, and our slope on this one is negative. They're the same. This one's more steeply negative, okay? So what does that mean? It's going from 10 to 0 relatively quickly. You would probably call that deceleration, but it's negative acceleration and slowing down relatively quickly. So we have positive velocities, and a negative slope means it's slowing down. A steep slope means it's slowing down fast. This blue one here, slowing down more slowly, right? It's a more gentle deceleration or a more gentle negative acceleration. Again, negative acceleration on the positive side, positive velocities, means it's simply slowing down. It's going east, but it's going from +5 going to east to 0 going east. All right. Oops, sorry, wrong one. There we go. Example number 4. This gets a little bit funkier looking at these now because now we're down in the other side. So again, positive velocities up here, negative velocities down here. This could be west. This is probably still east. if you want to talk about it that way, but it's in the negative velocities. So what's happening here? So let's take a close look at the signs of what we've got. So here we're starting at 0. Here we're starting at 0. Okay, it's kind of similar. And here they're both getting negative. This one maybe is going to -5, and this one's maybe going to -10 meters per second, right? By the way, this is kind of that idea of analyzing the graphs, is kind of finding these little relative points. It does help you interpret these. So it's going from 0 to -5. Well, what does that mean? Well, it means it's speeding up. It's going from 0 to -5. It's just going from 0 to -5 in the westerly direction. It's going that way as opposed to that way, whatever it is. So it's speeding up, but it's going west as opposed to that same line kind of angling up going to the east. So let's take a look at our slopes here now. We know our slopes are changing, right? So we've got a change in velocity, means that there's acceleration, A-C-C-E-L. This one's got acceleration as well. Our slopes here are negative, right? They're going downwards. But what does that mean? Does negative deceleration or negative acceleration mean it's slowing down or decelerating? So if you take a look at this, it's going from 0 to -5, or this one's going from 0 to -10. This one's actually doing it pretty fast, right? It's a pretty steeply negative sign. So here we've got negative acceleration in negative velocity territory. That simply means that it is speeding up going in the westerly direction as opposed to speeding up going in the easterly direction. The red one is speeding up faster than the blue one. Its slope is more steeply negative than the blue one, which is more shallowly negative. So again, our slope tells us the magnitude of the deceleration, and you compare the signs of this to this. So if you got negative acceleration and you're below the x-axis, you're going in the negative direction, that's actually speeding up just west. That's all that means. Okay. Kind of the opposite, right? Here we've got something going from -5 to 0. This one's going from -10 to 0. So what are these guys doing? So let's take a look again. You should be able to hit pause and interpret this. We've got acceleration. We've got acceleration here too. These are negative velocities, and they are approaching 0. Therefore, they are slowing down, right? Slowing down, going from -10 to 0, -5 to 0. They are coming to a stop. They're just doing it in the westerly direction is all that particular means. So we've got our two accelerations. Here, the slopes of our accelerations are positive, and our velocities are negative. Again, the signs do not match. So if our acceleration is positive, but our velocities are negative, it's slowing down. When they match, it's speeding up. When they don't match, it's slowing down. It's still acceleration both ways. So this is positive acceleration in the negative direction. What? I know, it's weird. I know. Okay. Okay, this is a little bit different situation. This is one of those graphs when it's very misleading. And this is one of the ones that you got to really stop and think about what this particularly means, because it looks just like single straight line motion that should be consistent across the top here. So we know we've got acceleration, right? We know we've got it because there's slope here. It's not going constant velocity. Here it is starting up here at +10. So it's going east, right? Is that what we decided? And this would be west. So what does this graph mean? It's going from +10, and then it crosses the x-axis. So again, this is a super important point right here. This means that the velocity equals 0. This means it's coming to a stop, right? We've got a negative acceleration from positive velocities. This means that it is slowing down and coming to a stop. Well, then what does it mean after that? Now it's coming from velocity equals 0 to velocity equals -10. What does that mean? Now it means it's speeding up because it's still going acceleration, right? Acceleration is still negative here. That has not changed. But now we've got negative acceleration and negative velocities. So what does that mean? It means it's speeding up, going in the opposite direction. So let's tell the story of what this one is. This thing was going east, came to a stop sign, and then turned around and went back west and sped up and went away. So its position time kind of went like this. It went east to the stop, and then it went back west is kind of what it did. Again, our position time graph versus our velocity time graph Very, very different looking in this particular case. So again, look for those spots where it crosses the x-axis because you know it's coming to a stop. So it went from +10 to 0, east to a stop, and then changed direction and went to the west side of the graph and sped away, increased its speed. So here you've got negative acceleration the entire time. Here the negative acceleration was decelerating it because it was positive, slowing down. Here the negative acceleration is speeding up in the negative direction. I think I have one more. Yep, here's our last one. Okay, so again, another kind of misleading, weird looking graph. What in the hell does this mean? So here we are at -10 meters per second, right? So we're going west. And now what's happening on this graph? What's happening to our speeds? Starting at -10, and now our speed is approaching 0 meters per second. So we have acceleration. This acceleration is positive, right? Our slope is positive. So it's going from -10 to 0, slowing down. Okay, it was going west, came to a stop. Now what is it doing? It's going west again. It is still in the negative side of the graph in the second part of its motion. So now we have acceleration here that is negative because its slope is negative, and it's on the negative side of the graph. So it's going back up to -10. So think about this. It's going west at 10 meters per second, -10 meters per second. It approaches 0 meters per second, comes to a stop, and then it continues west until it gets back up to 10 meters per second. This is a stop sign. So you went west, came to a stop, and then sped up going west again. You never changed direction. This is the same direction of motion. You're on the negative side of that motion. You just changed your velocities. Your acceleration changed, but you really didn't change your physical direction because you stayed on the same side of the 0 line or the same side of the directional line, positive to negative. So again, these can be very misleading. Again, you got to kind of really stop and talk yourself through it, what it means to be a positive velocity versus a negative velocity. Again, I like to assign words like east and west to it as opposed to forwards and backwards, because forwards and backwards can get very misleading here. So east and west, north and south works really well as well. So this could be something that's going south, stops, and then continues south again, but speeds up. Again, talk yourself through it. Don't hurry on these things when you're looking at VT graphs. Take your time and look for that important landmark of crossing the x-axis and comparing your signs. If you're on the negative sign and you have negative slope, you're speeding up. If you have negative on the negative side of velocities, but you've got a positive acceleration, you're actually slowing down. If the velocity signs and the acceleration signs are the same, you're speeding up. If your velocities and acceleration are opposite signs, you're slowing down. So there you go. Hope you got something out of that, and I'll see you in the next video. Bye, guys. More math in the next one, so get your calculator ready. Bye.